In this video, we'll be solving this differential equation. So the key to solving this differential equation is to basically treat x as your dependent variable and y as your independent. So think of this, in other words, as x as a function of y instead of y as a function of x. So in other words, think of it the inverse of what you would think. So in order to do this, what you have to do is flip both sides. So dx over dy is equal to x plus y squared. And really the reason I'm doing this because I just don't know how to deal with x and y both being in the denominator like this. The problem is that there's an addition that separates them. If there was multiplication, then this would be a separable differential equation. But since this is addition, we cannot separate this. So we're just going to flip both sides. And now we want to subtract x. And so we have to introduce an integration factor. So this will be e, the integral, and then this is just a coefficient of x. So it'll be -1 with respect to y. Because remember, y now is our independent variable. So integrating this, we get e to the -y. And so that's what we're going to multiply both sides with. Now the left side is just a product rule for e to the -y times x. And so we're going to integrate both sides. So the integral and the derivative are going to cancel. So we get e to the -y times x. And that's equal to the integral of e to the -y times y squared dy. Now in order to integrate e to the -y times y squared, you would have to use integration by parts twice. And basically you would have to set u equal y squared. Du is 2y, dv is e to the -y, v will be negative e to the -y. And so you would have -y squared e to the -y minus negative, so it'll be plus, we'll say 2 times the integral e to the -y dy, which is y squared e to the -y. And then this would be, oops, I forgot the y here. And then, actually, this one you have to use integration by parts again. So you say u is y, du is dy, dv is e to the -y, v is negative e to the -y. So we have plus 2 and then times y e to the -y minus negative will be plus integral e to the -y dy. So yeah, so that's what you would have to do. And then the integral of e to the -y is just negative e to the -y. But basically, what happens is you can just factor it out like this. So the integral becomes negative e to the -y times a quantity y squared plus 2y plus 2. And so I kind of skipped a couple steps there. And then don't forget the plus c at the end. Now, I can get rid of the e to the -y's. So I'm just left with x equals -y squared plus 2y plus 2. And then plus c. So remember, this is x as a function of y. Now I can use this initial condition. So here you have to be careful because x here is -2, y is 0. So plug in x equals -2. These are all going to cancel. So you're just going to be left with, these first two are going to cancel. You're going to be left with a 2 and a negative. So it's -2 plus c. And so c has to be 0. And so the answer to this differential equation is x equals -y squared minus 2y minus 2.